In our course of investigation, we chose an experiment about lyophilization. And the problem was that lyophilization processes generates freezing and drying stresses, destabilizing the protein structure caused by dehydration. The purpose of this was to stabilize the proteins for better usage. And we chose an experiment that a custom-built internal reflection FTIR accessory was used to follow the entire freeze-drying process of solution, consisting of 49.4 milligrams per milliliters of lysozyme in the presence and absence of 10% sucrose in real time. Studies were carried out using D2O as a transparent medium in the infrared region of the protein amide bands. The potential self-association of the protein is in the presence of sucrose was investigated using dynamic light scattering. The hydration levels were determined using a multiple regression equation and differential scanning calorimetry DSC, that's how it's abbreviated, permitted characterization of the final lyophilized product. Moisture content was determined using color feature titration. The hypothesis of the problem of this experiment was that adding sucrose to the protein will help stabilizing the protein structure, measuring the changes in the amide 1 band of lysozyme caused by dehydration encountered during lyophilization. And the new hypothesis was that adding sucrose to the protein will have no change in stabilizing the protein structure. The variables were that, well, the dependent variable was that protein stabilization in the 49.4 milligrams per milliliters of lysozyme. That was the dependent variable. The independent one is the presence of sucrose and the absence of sucrose and the control variable is the dioxide D2O as a transparent medium. The analysis was that throughout the freezing and drying, minimal changes were presented. The greater changes in frequency and band width were seen in the absence of sucrose. The lyophilized cake had properties of a Tg of 50 centigrade and contained 40% moisture weight. So, in conclusion, the inclusion of sucrose served to minimize perturbations of protein structure caused by freezing and dehydration stresses encountered during lyophilization, compared to studies conducted in the absence of sucrose. The results support the water replacement hypothesis and underscore the role of the sugar in preserving a native structure in the dried state. This investigation demonstrates the usefulness of infrared spectroscopy in evaluating lyophilization process parameters and formulation designs.